Okay, so I'm just going to talk about a couple of common issues that can cause no backlight and no LED drive voltage on this Vestel 17IPS20 power supply. This is the actual first revision of this supply. This is not the P version, which doesn't have these 6 diodes here. It's a little bit different in the design. Now the fault with this is there's no boosted LED voltage for the LED drive area. Now these supplies, they have the LED driver built in over here, and what the LED driver is, it just creates the drive voltage at the right current used by the LEDs in the screen, because there's a series circuit, so you can't just apply 3 volts, which is what the LEDs normally use. You have to apply a lot higher voltage if it's a series circuit, so because each LED will drop a voltage. Will have a voltage drop across it, but these supplies, they're not the best. And I'm going to talk about what can cause no backlight. Now, the fault on this one is I'm not sure. I'm in the process of diagnosing it, so I'm literally out on my own for this, but I'm going to diagnose it hopefully on video, and then after I've diagnosed it I shall talk about what causes no backlight on these. Now, if the backlight is working, you should have, which this diode goes straight to this connector by the way, you should have, I think, around 160 volts with the supply and the TV on this red lead here going to the positive side of the LEDs, and it will be the same on this diode here and across this cap here. It should be around 160 volts, I think 180 volts on startup. Now if it stays at 115 volts and you get no backlight, that means the driver has failed. It has to go up to 180 volts, and then the PWM circuit kicks in, and then it lowers to 160, I believe. And if it starts off at 180 and lowers back down to 115 volts, which you should have 115 volts on the cathode side of these diodes at all time, that means, and it lowers back to that on the output here, that means you have a failed LED in the screen. But the fault with this one is there's nothing on these diodes, which tells me there's a problem over here in the switching section for this supply. So when these are working too, you should have, this transistor should be running, driving this transformer. You should have around 380 volts, I believe, across these caps. And that's what you should have for this supply. Now this doesn't have, it's not as exactly active PFC, but this MOSFET here boosts the voltage for this transistor. I'm not entirely sure why, I haven't looked into it that much, but the TV is in standby right now, so what you can do is turn it on, measure the voltage across that cap there, and if that's lower, I believe the problem is either in this section here with this MOSFET, and that's where I've got to so far at least. So what I shall do though on video is just show you the LED drive section. It's totally dead, there's no voltage over here whatsoever. There's about 1 volt or so from what the meter picks up, which tells me that the transistor is not running. So black probe on chassis ground, and I'm just going to put my red probe on the cathode side of the LED output diode there, and find the remote, which is vanished. Here it is. Right, so I'm turning on the set now. As you can see, set is booted up. About 1 volt across that. That's not good. Now, if there was a fault with the LED MOSFET, the boost MOSFET, and that was shorted, what would actually happen is we would get 115 volts across these, and then it would disappear straight away. But we don't even get that at all, it's just dead. So that tells me straight away that the LED driver chip and the LED MOSFET and this diode and these diodes are good. And that tells me straight away there's a problem in the switching transistor section. Of course there is, because it's a Vestel. So next, I already know where the fault is on the supply. Well, I don't know which component it is, but I know where the fault is. But if you have no voltage over here on these, you need to see if you have above 330 volts on this filter cap here. Now, to test a filter cap, you need 600 volts DC on your meter, and then you put your negative probe on the negative side of the cap and your red on the positive. Now, I believe that's way too low for this transistor here. It needs to be a lot higher than that. So, what that tells me is there's a problem with this MOSFET not turning on enough. Now, these supplies don't have a standby circuit, by the way. They have 12 volts run constantly, and then it's switched by a little DC converter on the main board. So, that tells me straight away either this transistor is not being turned on, or something else is up with it. Now, this isn't shorted, but I'm going to talk a couple of common issues with these supplies first before I take this back out again and diagnose it. Here's another one which I couldn't be bothered to fix because I had some on hand. Now, anyway, if you're only getting 115 volts on the LED output here, and it's 115 volts DC, and it doesn't collapse, it stays up at 115 volts exact. Problem's going to be with this chip here. This is the LED controller. Now, you can't just replace these with any random MPS chip, it has to be the exact number, and the reason is because the different model numbers of these are designed for different size screens and different amount of LEDs. So if you put like a one that's designed for a 50-inch in a 40-inch TV like this, it's probably going to drive the MOSFET too hard, and the set will cut the backlight out probably. So yeah, if you get no boosted voltage and the MOSFET isn't receiving a VCC voltage, it's likely this chip, and it's nothing uncommon. In fact, I actually have a couple of these. The ones used on the 40-inch version with the VES 400 panel are MPS3394, the controller chips. So, and this can also, when the supply heats up, cause the backlight to cut out. So, and to see if the VCC voltage goes from the MOSFET, you can just solder a wire and then have it hooked up to your meter with the supply still in the TV to test it. And that can also cause that issue, the controller can. Another common issue is, as I said before, you get 115 volts and then it shuts down, and this diode appears to be shorted. Now, it can either be this diode or it can be the MOSFET. Now, the boost MOSFET's rarely short on these from what I've seen, which is that little device there, but it can happen. And if that does short, it can make that diode appear to be shorted. So what you should do is remove one leg of the diode, see if it's still shorted. If it's not, remove the MOSFET. That's normally all that blows up, is just the MOSFET, from what I've read. I've never had that happen. And that diode can go, from what I read. Apparently another common issue is one of these diodes can short, which causes no 115 volts across this. But you will get 380 volts, I believe, across this cap. And that's pretty much it that can go wrong in the LED drive area. They're not too bad. Now the next common issue is this transistor here, the gate controller for it, which this little chip here, that fails and the transistor no longer switches anymore, which means you're not going to get any voltage over there. So, and it's a similar way to test that, but you shouldn't test this with the TV on. You should see what ohms reading you get to ground with this device, and if it's low on a couple of the VCC pins especially, replace that chip. And I've actually had that fail before and it sorts the issue. Another issue is this transistor can short circuit and it'll blow this resistor out badly, and if that resistor does actually blow quick enough, it won't blow the mains fuse, from what I've actually seen. But if it doesn't blow quick enough, it will short this diode, these 4 diodes, and then it'll blow the fuse. But if that resistor doesn't blow, if that resistor blows quick enough, open circuit, and the transistor's shorted, it won't actually cause the fuse to blow, and the TV will still turn on, but with no boosted backlight. So yeah. Another issue is you don't get any voltage across this cap whatsoever. You get 0 volts. That can be caused by this diode here, which is an MUR460AX. It doesn't fail short circuited from what I've had in the past, and I've had this diode on this exact supply and other Vestels fail. It doesn't go short circuit, but if you put your red probe there on the cathode and your black one there, you'll get a very low voltage drop across it, which means it's basically failed. And it gets really hot as well. You can actually see the PCB go brown if you leave it actually soldered in the supply hooked up to mains. So this diode can also fail, and from what I read, that can short, but I'm pretty sure if that did short, the mains fuse would blow. But from what I've seen, that can actually short circuit, which can cause no backlight too. And I believe the issue today with this, well, that supply, is this MOSFET isn't being turned on. So I'm suspecting probably the controller is failed. So time to get this out, and I'm going to investigate the VCC voltage, or the VCC to ground on that controller on this supply here. So let's do this. Well, I'm finally onto something on this power supply. I'm getting low ohms across this ceramic cap here near the booster MOSFET. I think it's C127. I'm just getting low ohms across it, and a pretty low voltage drop. And my meter did beep a few times, but then it sort of creeped up a little. Now the controller seems to be okay. This cap is a little, it just seems a little off. So what I'm going to do is compare the two boards for you there, and testing that little cap. And I might try swapping it over. I'm not sure what the value is of that, but if that's possibly the issue, I shall find out what value that cap is. So I'm just going to use diode mode to get a voltage drop. So here's on this other board, which the other transistor blew up and I couldn't be bothered to fix. So C127, that's the voltage drop I get across it. Now there is actually a diode, I believe, in parallel with this. Yeah, in parallel. So you do get a bit more of a voltage drop another way than the one. You see me testing that. It's this one here. That's on the one board, and then on the first one, it's not looking that good. You can see that just as well. push that over a little. Sorry about the camera work. So it's this cap here. Short circuited. My meter's beeping across that. Which means that there's almost a dead short across that. And it's the same either way. That shouldn't be like that. Now there's a diode I think there. That's not showing up as shorted. And I'm not too sure whereabouts that goes into, but I couldn't find anything else that's obviously causing that to show up as shorted along here. The transistor's good, you know, as I shall show. I can actually turn it on pretty quick. You know, the transistor's good, you know, a couple of the devices behind it are all good. Diodes in the area and in the controller are testing good, but this cap is showing up as shorted. If I do an ohms reading across that, we shall see. Get about 50 ohms across that. It shouldn't be that low. So I'm probably going to take that out of circuit and test it out of circuit. Apart from that, I don't know what else could be causing that, but it should not be that low across that cap there. I'm surprised this hasn't blown up, to be fair, but I'm going to take that cap out and see if I can find anything else, so I'll do that now. Alright, so I found the issue. It is C525, which is this little ceramic cap here. It's short circuited. The cap itself is shorted. After pulling that, there is no longer a short on the pins on this controller or that cap there. And if you meter the traces, they are connected directly to each other, so if that's shorted, that one will show up shorted as I found. Sorry. So what I'm going to do is just take this one off this scrap board here. That's C525 there. Put it on this. Put the controller and that cap back on, and we'll give this a test. Even though it is nearly 1 in the morning, so I'm on Xbox and I'm, well, in an Xbox party and got nothing to do. So I'm just going to show you this cap is shorted, and it is the same ohms reading that we was getting across the other one. And I think about 0.58 or so. Of course, this is going to be. See, it's not dead short, 'cause sometimes it'll appear like it's not a dead short, but sometimes it'll just beat the meter. There we go. Of course, it is mega hard to do with these probes, and when it's this late as well. I'm going to try and pick this up and do it. No, that was me shorting out the probe. This little thing just wants to go and slide everywhere. There we go. That's the reading of the cap. For some reason it makes the speaker and the meter go really weird. That's me shorting out the probes, but when I do it with the cap, I guess it must be acting as sort of decoupling the meter probes, so it's making the speaker and the meter go weird. But this little guy, C525, short circuit bin, and I'm going to steal the one off this board, and I'll also use my ESR meter and get a capacitance value on that cap. I'd say it's probably about 22 microfarads or so. I'll get a capacitance value, so, and I'd say it's around 50, well yeah, it is 50 volts, I know that for sure. And I'll get a cap value for you, and then if you ever do get this, you can just order the actual value of it. So actually I can use the capacitance meter on my meter, that might be easy to do. So yeah, I'm going to solder the other controller, another cap back in, and we'll steal this one. Yeah. So yeah, let's do that. Alright, so it's the next day and I've replaced that ceramic cap with a good one. I think it's actually a 1 microfarad cap rather than a 22 that I declared last night. It was quite late, so I'll replace that cap and we're going to do a resistance check. Again. I took that cap off the other board, by the way, so here's the resistance across it now, or the voltage drop actually, sorry. Oh, that was my fault. As you see, 467, and across the cap that I found was also bad. This is in parallel with the other one, by the way. And that's all good now, so we are going to shove this in the TV and give it a power up test, see what happens, see if it blows up, see if it works, you never know. Nothing else I could find wrong on this, so let's get this IPS20 back in its set and see what happens. So yeah, C525 replaced. Right, so this is a smoke test. Booting up. What's going to happen? Prepares. Oh! Backlight. We have a backlight, people. On this power supply now. Sweet. Nice blue screen. Oh, I don't know what that was. Some plastic or something. Picture is working. Backlight is on low. I can't actually adjust it. Now, the reason is because I had to replace the main board in this set. This board is out of a different set because the original one wouldn't boot up for some reason. And when I swapped it for this one and a 17MB82, the set did boot up. So I'm wondering, was the original board faulty? It might not have been, so what I'm going to do is put the original main board back in and see if the set boots up, and if it does, then I know that the power supply was causing it to lock out, because originally the standby light would just flash once and then it'd stop. But swapping the board seemed to sort that, so I'm going to get the original board and see if the set boots up. So I'll do that now. Right, so I've got this original MB95 here, just stacked on top. Let's see if it boots up or not. Nah, that one's still dead. Okay, so yeah, that original board is actually faulty still. So I wonder what the issue is with that, but I do not really care because I've got another one in place, so that'll do. But yeah, the power supply is at least fixed. Plug this guy back in. Here's a standby, of course. Backlight on. Sweet. That's a VES 400 fixed, 17IPS20, by replacing that stupid little ceramic cap that had shorted. I'm not going to take this back out, but that is sweet. So what I'm going to do is run this for a bit, and I'll lean it against the wall and turn the backlight to low and see if I can actually adjust the backlight, because it didn't look like I was able to with this, but I'm pretty sure the board should be the same, because that board is actually out the same TV. But I'll have a play around, but yeah. That's his supply fixed, so another mystery solved. With these Vestel supplies, they are riddled with problems, so anyway, let's see if I can adjust the backlight and keep this running for a bit, and hopefully it doesn't go boom. Because I know from another video that transistor can blow if that cap does short, but I only watched that today, so let's set this up for a bit. Alright, so I've had this set on for about 20 minutes now, and let's just get the hour count. Around 9,000 hours, 8,000 hours I'd say. Well, I think 10,000 hours is 600,000 minutes, so it's literally around just under 9,000 hours, so yeah. I guess it's done alright. That is quite a lot of use for a Vestel TV. I mean, the Samsung one that I fixed for us downstairs, that we've had for 2 years now, that only has around 2,300 hours use on it. So, actually, yeah. So that is a ton of use for a TV, which, that's why it's failed. Just because of how much people are watching these things, they just wear out so fast. But I've got the backlight on low. I was just being a dork earlier, so let's just go up to max. Always keep it on low for the Vest 400 or any LED TV actually. The power supply does buzz a little, but it's that little transformer there. If you pinch that together, the buzzing will stop. And see that cap there, C525, directly under Q301. I got the replacement mainboard on there, and see the thermal pad under that I put on there because I stole the heatsink off it, but got that initialed, and I'm going to switch this off, put the back on, and get it in the testing area over there. So mystery solved. So I'm going to test this now properly for 24 whole hours. Well, I don't test it in this room, I'll put it downstairs to test, but yeah, I run these for 24 hours solid, so let's do it.